In studying nth order linear ODEs, ato lang for the meantime, i-limit atong attention or mo-focus lang sa linear homogeneous ordinary differential equations where these are constant. So ato lang ginatawag nga linear homogeneous ODEs with constant coefficients. Okay, so it has the standard form y to the nth prime plus the coefficient, which is constant a sub n minus 1 times y to the power y to the n minus 1 prime plus so on and so forth, a sub 1 y prime plus a sub 0 y equal to 0 because homogeneous man. Now, so we'll introduce a parameter lambda para ma-transform ang atong linear ODE into a polynomial equation. No? So if polynomial equation siya, it's easy for us to determine the roots sa kaninga equation, di ba? So lambda would be our dependent variable solving for lambda, wherein lambda would be our roots. We have y equal to this one. So this is the solution to our linear homogeneous ODE with constant coefficients. Okay, so ang derivation ani or ang proof is pwede naman nato na makita sa lahi ng mga sources pero di man nato concern as of the moment. Ato na lang i-believe as is. Nga mo ni siya ang solution sa atong kani nga linear equation. Okay? So the solution is equal to, so if kuan pa ni, if part pa ni siya sa non-homogeneous nga solution, we could denote this one as our y sub h. Should be correct. Y is equal to constant C1, arbitrary constant C1 times e to the power of lambda 1 times x, where our lambda is one of the roots sa kaninga linear equation na to, or I mean sa kaninga polynomial, Okay? So C1 e to the power of lambda 1 times x plus C2 times e to the power of lambda 2 times x, so on and so forth, c sub n times e to the power of lambda 1 times x. So kung unsa ni nga order nga differential equation, maupod ang number of roots, maupod ang number of linearly independent solutions. Okay? So for a special case where our order is 2, our n is 2, so second order, we could reduce this formula, or I mean this equation, into this form. Y double prime plus a sub 1 y prime plus a sub 0 y is equal to 0. No? So, quadratic equation. Especially kung ato pag i-introduce ang lambda nga parameter. Lambda squared plus a sub 1 lambda plus a sub 0 is equal to x. So, this is for the second order linear homogeneous ordinary differential equation with constant coefficients. So, sa iyang mga solutions or sa iyang mga categories of solutions, possible solutions, we have 3 cases. Okay? So, of case 1, case 2, case 3. Case 1, where the roots, so if this is to the second order, we would be expecting, or quadratic equation man, nga na siya duha ka roots. So, we have, first case, real and distinct roots. Meaning, lambda 1 is not equal to lambda 2. Okay? So, the solution for that one is this one. Y is equal to c sub 1 e to the power of lambda 1x plus c sub 2 e to the power of lambda 2x. What if the roots are repeating? Meaning lambda 1 is equal to lambda 2. Okay. So, yan yung may tabo. Okay, this is the solution. If you compare it sa taas, no? So, if lambda 1 is equal to lambda 2, so dapat pwede rapod niya siya nga lambda 1. No? It doesn't matter kay parera man. Ang kalayan lang nila is, ang second expression or ang second set of linearly independent solution is nanay x. Alright? Yeah. Next is, or I mean next case, is what if complex ang solution? So, our lambda is equal to complex conjugate a plus minus j. I use the letter j to denote n minus 1. I mean, j is equal to square root of negative 1, square root of negative 1 JB. Right? So, ang solution would be equal to this one. C1 e to the power of A times x cosine B of x plus C2 e to the power of A times x times sine B of x. This is if complex ang roots. Okay. So, this will only apply for a special case that our linear equation is of the second order.